Hey guys, we're going to shift gears a little bit and we're going to look again at the graphing feature or graphing part of the exponential functions. Remember that it has that asymptote that is like that horizontal line that it gets really close to but never touches. It usually has an x-intercept, but not always. And then it will also have a y-intercept at some point. So what we're going to look here is at vertical shifts and horizontal shifts. So just like we looked at those for our quadratic functions, we're going to look at those for exponential functions as well. It's going to work out almost the exact same, except our parent function just looks a little bit different. So let's take a look. So our exponential parent function is going to be y equals 2 to the x power. So remember, our variable is in the exponent for an exponential function. So this is our parent function here. And for a vertical shift, you're going to see plus, I use just the b, okay? So remember, if b is positive, it's going to be a shift up. And if b is negative, it's going to be a shift down. And that's what will go there. So that's outside of the exponential and not inside the exponential, the exponent there next to the x. So we're going to look here. So let's look at we're going to describe the transformation. So I have f of x is equal to 2 to the x. So that's my parent function. And then I have plus 8. So since this is a plus 8, so it's a positive, that means it's going to be a shift up 8 units. And then if you look at the second example here, we have our f of x is equal to 2 to the x, which is our exponential parent function. And then we have a minus 4.5. So that since that minus, it's a minus 4.5, so b is negative, then I'm going to have a shift down 4.5 units. And then we're writing an equation based on the transformations given based on our information from the exponential parent function. So it says write an equation of the exponential parent function that has been shifted down 3 units. So what we're going to have here is f of x or y. I'm just going to use y equals, and it's going to be shifted down 3 units. So I'm going to have 2 to the x, which is my parent function, and then I'm going to have minus 3, just regular outside, not in the exponent. And I'm really specific about that because you'll see in the horizontal shift, it is in the exponent. So let's look here. So still 2 to the x is the exponential parent function. And then we have 2 to the x and then plus b. B is in that exponent there. So we're going to describe that transformation there. So notice that I have 2 to the x, and then I have this plus 6 right next to the x. So just like you had that before with the quadratic, remember it's right next to the x, that shifted it right or left. And just like with the exponential function, our quadratic function, remember our plus b, if it's positive, it's going to be a shift to the left. And then if it's minus, it's going to be a shift to the right. So since in our first example, we have f of x is equal to 2 to the x plus 6 right next to the x in the exponent, that's going to be a shift left 6 units. Now, if you'll look at the next one, this one a little bit tricky there. You'll notice we have 2 transformations because we have a minus 1 in the exponent next to the x, and then we have plus 13 that's not in the exponent. You can kind of sort of see the differences there. So since I have the minus 1 right here, that's going to be right 1 unit. And then since I have plus 13 right here, that's going to be up 13 units. Okay, so that there is going to be, so you could have 2 or just 1. So we're just looking at vertical and horizontal. It's not going to get any further than this, so don't start freaking out on me. All right, so write the equation of an exponential parent function that has been shifted to the left 7 units. So I have y equals 2 to the x, so I'm going to keep that, and then I have a left 7. So left 7, you would normally think, oh, that's negative 7, but remember when you move right or left, it's going to take the opposite sign, so it's going to be plus 7 in the exponent. Okay, so be very careful about that. On your open-ended problems, I'm probably going to have y equals 2 to the x, and then I'll have a blank, and then I'll have a blank out here. So you want to make sure you add in those signs. And if it only shifts one way or the other, so if it only shifts right or left, your big number out here would be a 0. And then if it only moves up or down, the exponential up here would be plus or minus 0. Okay, make sure you add those signs. And then if it only shifts one way or the other spot, I guess you so to speak, would be 0. So make sure you do that. And I would just go ahead and do a plus a 0 instead of minus 0. That's just me, but you do you. So this is it for our exponential functions. We're going to wrap up all of this. We've got a test coming up, and then you also will have we'll move on to radical expressions, moving on next week after that. And make sure that you're checking in with me if you have any questions. I have a Schoology conference going on every weekday at 3 o'clock. And then we're going to have a scheduled one at Wednesday at 6 o'clock, whether it's on, I'm trying to decide. Make sure you look in your messages. I think I'm going to try to do Zoom or Google Hangout for that one there. And that'll just be in the evening. I know a lot of you are working late in the evening, so that's why we're going to have that then. So it's, I miss seeing you guys, and I'm ready to get back to school. We'll see you guys later. Bye.